rod of radius r. Here is a current of I1, so I specify it as I1 into the page with a uniform current density. There is also thin wire at a distance 2r away from the surface of the rod. So we have here current 2. Then what we have, what is the magnitude and direction of the current? So we have to find the magnitude and direction of the current in the thin wire, so that magnetic field at point P, so net magnetic field, so B net at point P equals to magnetic field at the center of the rod. So basically magnetic field due to current 2 is equal to the B net. Okay, so the condition is that we have to find the direction and the magnitude of the current. The condition is B net is equal to the magnetic field B2, okay, due to the current 2. So how can we find it? It also specifies that you have to use plus sign for the current into the page and negative sign out of the page. Okay. So let's suppose that the current I2 is into the page. Okay. If it's into the page, then at point P, which is this point, at point P, magnetic field due to the current 2 will be, using the right hand rule, we can say that is downwards, okay, which is B2 due to the current 2. Then magnetic field at point P due to the current I into the page, so that means at point P will be upwards. So this is a B1 due to the current 1. Now what about at the center of the rod? So at the center of the rod due to the current 2, it will be again downwards. So this one I call it B2 due to the current 2. Okay, so let's write down then. B net at point P is basically equal to the B1 minus B2, and it's equal to the B2. Okay, so B1 is equal to 1. Is equal to what? So B1 is equal to the mu naught current 1 divided by 2 pi r distance. So what is r distance here? The r distance is basically mu current 1 divided 2 pi. So that distance, r is equal to the 2r. Okay, that means it's equal to 2r. Okay, we found them. Now what about B2? B2 due to current 2 is equal mu naught current 2 divided by 2 pi. Now that distance is just r. Okay, now finally so B2, so let's define it more. So B2 at the center of the rod. Okay, so is the center of the rod. Now what is the formula of the B2 at the center of the rod? It's equal to mu naught current 2 divided by 2 pi. Now the distance is basically 3 r's, right? 1 r. So this is the whole distance. The whole distance from here till here will be 3r. So that means 3r. So I think that's it. If you plug all the numbers, you should get the answer. Okay, so that means finally what you will get? You will get so B1 is equal here mu naught current 1 divided by, this is, let's make it 2 pi 2r minus B2 at point P is mu naught current 2 divided by 2 pi r, right? And that's equal to the, since we're defining the downward direction as a negative, it will be negative B2 center of the road becomes mu naught current 2 divided by 2 pi 3r. So here we can cancel out this mu's, we can cancel out 2 pi's, and we can cancel the r's. So we end up finally current 1 divided by 2 minus current 2 is equal minus current 2 divided by 3. So that's it. Plug the numbers.